Welcome to another deep dive. Today we're diving into the cosmos with this theoretical physicist, Abhijit Chavda.
Okay.
You sent over this really cool interview with him, and he
Yeah.
talks about everything from searching for alien life to like really fascinating theories about dark matter.
Yeah, one thing that really struck me about Chavda was this infectious passion that he has for the universe. It's like he approaches these really complex ideas with a sense of wonder that's honestly, it's contagious, and he's got some really unique perspectives.
Yeah, absolutely. So, like, one of the things that really stood out to me was his take on dark matter and dark energy. I mean, just wrap your head around this for a second. The idea that most of the universe is made up of something that we can't even see, that's just mind-blowing to me.
Yeah, for sure. And what I find really fascinating is that he's actually developing a new theory that connects these things called microscopic black holes to dark matter.
Oh?
It's pretty groundbreaking stuff.
Microscopic black holes. Wait, so like not the giant cosmic vacuum cleaners that we usually think of, but like tiny versions of them. And those are explaining one of the universe's biggest mysteries.
Yeah, it's wild, right? It's pretty complex, but basically his theory suggests that these microscopic black holes, which were formed during the Big Bang, they could actually have the right properties to account for all of the strange gravitational effects that we observe. And, we've always attributed those to dark matter.
That's why.
So he's really challenging the prevailing theories out there.
Well,
And it's sparking some very, very interesting debate in the scientific community.
well, it really just, I don't know, it drives home the point that we still have so much to learn about the universe.
For sure.
Okay, so shifting gears a bit, Chavda also talks about the possibility of us finding alien life, and not on some like distant exoplanet,
Sure.
but right here in our own solar system. Like he even mentions Jupiter's moon, Europa.
Yeah, Europa is a prime candidate. It's got this subsurface ocean, but, he also pointed to places like Titan and Ganymede as potential hotspots.
Wait, Titan, that's the moon with it's Saturn's moon, right?
Got it.
The one with the methane lakes and stuff?
Yeah, exactly. And Chavda speculates that if life does exist on Titan, it would have to have a completely different biochemistry than anything that we've ever seen here on Earth. It'd have to be adapted to these incredibly cold temperatures and this liquid methane environment.
So not little green men, but like something even weirder.
Potentially.
Oh, wow. Okay, so it's not just those moons, though, right? He also mentioned Mars.
He did. He argues that millions of years ago, Mars was a much more hospitable place than it is today. Like, picture this. Oceans, a thicker atmosphere. He suggests that it may have even been a prime location for life as we know it. And get this, he thinks there might be evidence of it, like frozen beneath the Martian surface.
Frozen evidence, like what, like Martian bacteria or something.
Well, he didn't rule it out. He even pointed to this fascinating example of a Martian meteorite that was found right here on Earth.
Oh, wow.
And when scientists analyzed it, they actually found these microscopic structures that bear a striking resemblance to bacteria. Now, he emphasized that this isn't definitive proof, but it's a very, very tantalizing clue.
It's like something out of a science fiction novel, but it could be real. That is so cool. So if Mars was once so habitable, like what happened? Why is it now this cold, dry desert?
Well, Chavda explained that Mars lost its magnetic field. That magnetic field acts as a shield, protecting a planet from harmful solar radiation. Without it, the Martian atmosphere was slowly stripped away by solar winds over millions of years, which caused the oceans to evaporate.
So Earth's magnetic field is like our own personal force field. It's protecting us from a similar fate.
Exactly.
That's kind of a sobering thought, actually. Okay, since we're talking about Mars, I have to ask, what does Chavda think about all this talk about terraforming Mars? Like turning it into a second Earth, kind of like what Elon Musk is always going on about.
Yeah. He seemed pretty open to the idea, at least from a theoretical perspective. He did describe it as a massive planetary engineering project that would likely take centuries, if not millennia, to complete.
Millennia.
Mm.
That's like longer than human civilization has existed.
I know, right?
Wow.
It's a long-term endeavor for sure. But he suggested that if we could find a way to heat the Martian surface, it could potentially trigger a chain reaction. And this could melt those polar ice caps and thicken the atmosphere.
How do you even begin to heat an entire planet, though? Like, are we talking giant space heaters or something?
This one's crazy, right?
Yeah.
But one idea that he mentioned was using these gigantic mirrors to reflect sunlight onto the Martian surface, like specifically target the poles.
Okay.
So imagine like a massive mirror orbiting Mars, and it's directing solar energy down to the surface like a cosmic magnifying glass.
That's mind-blowing. What an incredible like feat of engineering that would be.
Yeah.
Were there any other, perhaps less conventional methods that he discussed?
He did mention one faster, though, much more controversial approach. Nuclear weapons.
Nuclear weapons. He's talking about nuking Mars.
Yeah, he acknowledged it was a radical idea, and he emphasized the potential dangers, of course, like the radioactive fallout. But it was more of a thought experiment, just highlighting the sheer scale of what it might take to terraform a planet.
It's definitely one way to get things heated up.
Right.
Maybe we should stick with the giant mirrors for now.
Probably a good idea.
It's incredible that we're even having these conversations, though. It makes you wonder what makes Earth so special. Like, why haven't we seen other planets like ours?
Well, Chavda actually referred to Earth as this kind of a Goldilocks planet.
Goldilocks planet. I've never heard that before.
Yeah, it means that, Earth is in this perfect position relative to the sun. It's not too hot, not too cold. Like, it's just right for liquid water to exist.
So, like, if we were any closer to the sun, we'd be more like Venus? Is that what you're saying?
Yeah, exactly. And if we were any further out, our oceans would be frozen solid, kind of like on Mars. And the fact that we've got these vast oceans on Earth, well, that's, like, essential for life as we know it.
Right, but that is really lucky when you think about it. It makes you wonder, though, like, how did life get started here in the first place? Did it just, like, spontaneously appear? Or did it, maybe Chavda mentioned this, did it travel here from somewhere else?
Well, that is the big question, isn't it?
Yeah.
He talked about this idea called panspermia. It's this idea that life on Earth might have actually originated from, get this, microorganisms that were carried here by meteorites or comets.
Oh,
and there's actually evidence to support this.
Evidence like what? Did they, like, find alien microbes frozen in a comet or something?
Even more basic than that.
Oh, yeah.
His research has actually uncovered the presence of amino acids, and those are like the building blocks of proteins and DNA.
Right.
And they're finding them in meteorites and asteroids right here in our solar system.
So those tiny little ingredients for life are, like, just floating around out there.
It's pretty incredible, right?
That's wild.
And, during Earth's early formation, billions of years ago, our planet was bombarded by asteroids and comets.
Right.
And it's entirely possible that those impacts could have delivered the seeds of life to our young planet.
Wow. That is mind-blowing.
Yeah.
Speaking of, like, exploring the cosmos and everything, Chavda didn't just talk about the origins of life. He also kind of delves into our own efforts to explore space. Like, he specifically mentioned this whole thing with us going back to the moon. Like, why after all this time are we so interested in going back to the moon? Like, haven't we been there, done that?
Well, what he suggested is that the motivations for going back to the moon are very different this time around.
Okay.
So
Wow.
initially, it was all about geopolitics and national pride. You had the U.S. and the Soviet Union, and they were locked in this race to prove their technological dominance, especially during the Cold War.
So it was more about saying, like, my rocket is bigger than yours than actual scientific discovery.
Essentially, yes.
Wow.
But now you see there's this growing interest in lunar resources. We're talking about things like helium-3, which could revolutionize energy production, rare earth elements, those are crucial for various technologies, and even water ice, which could be incredibly valuable for future lunar settlements.
Okay. So instead of planting flags, now we're eyeing the moon for its resources.
It seems that way. And, Chavda pointed out that this new Great Moon Rush, it's already creating some tension between nations. The U.S., China, Russia, they're all emerging as the major players in this new space race.
What about India, though? I mean, we've been making some pretty significant progress in space exploration ourselves, haven't we?
Absolutely. In fact, Chavda, he actually praised India's space program, especially how cost-effective it's been. He highlighted the success of the Chandrayaan missions. India became the first country to successfully land a spacecraft on the moon's south pole.
That's right.
And they even achieved this remarkable feat, sending a spacecraft to Mars on its very first attempt.
Wow.
Something no other country has ever accomplished.
That's amazing.
Yeah.
I feel like we don't get enough credit for our achievements in space sometimes.
Yeah, I agree. Chavda even compared ISRO, the Indian Space Research Organization, he compared them to DARPA.
I know ISRO, but what's DARPA?
So DARPA, that's the U.S. Defense Advanced Research Projects Agency. It's kind of like this breeding ground for innovation in the United States.
Okay.
They've funded the development of some of the most transformative technologies in recent decades, things like The internet, GPS, even stealth technology.
Wow, I had no idea the internet had military origins.
It's true.
Wow.
And that's precisely Chavda's point. He believes that with the right investments in scientific research and education, India has the potential to become a global leader in innovation, and not just in, space exploration, but in countless other fields as well.
That's a really inspiring thought. Okay, so back to the moon for a second. With all this talk about these new missions and everything, it just made me wonder, are there still mysteries to uncover there? We've been sending probes and rovers to the moon for decades now. Isn't it just a big, dusty rock at this point?
You might be surprised. There are still tons of mysteries surrounding our lunar neighbor. For one thing, scientists are still trying to fully understand how the moon formed in the first place.
I always just figured it was like a chunk of Earth that got knocked off somehow.
Well, the most widely accepted theory is that this Mars-sized object collided with Earth billions of years ago.
Okay.
And then the debris from that impact, it eventually came together and formed the moon. Quite a dramatic origin story.
It's like a cosmic hit and run. That makes sense, but you said there are still unanswered questions.
Oh, yeah, definitely. Like a lot of the details about the impact, the composition of the early moon, its evolution, we're still piecing all that together. And then there's this whole dark side of the moon mystery.
You mean the fact that we only ever see one side of the moon from here on Earth?
Exactly.
Yeah, that's always kind of weirded me out.
Well, Chavda was saying that the far side of the moon, the side we don't see, it's a really intriguing location for scientific research.
Okay, how so?
It's shielded from all of Earth's radio transmissions. So it offers complete radio silence.
Radio silence. Why is that a good thing?
Imagine the possibilities. It'd be the perfect place to build telescopes and other really sensitive instruments, because then we could study the universe without any interference from Earth's radio waves. It'd be like listening to the faint whispers of the cosmos without all the background noise.
That's so cool. It's like setting up an observatory in the quietest place imaginable, but this place happens to be on the moon.
Exactly.
That's amazing. Okay, so we've established the moon is way more interesting than it gets credit for.
Right.
But we have to address the elephant in the room. Those conspiracy theories that say that the Apollo moon landings were faked. Did Chavda have anything to say about that?
He did. And, in typical Chavda fashion, he tackled it with this really great blend of humor and skepticism.
Okay, so what's the verdict? Did we really land on the moon, or was it all a big hoax?
He said he's 99.9% certain the moon landings were real.
Okay.
He pointed out that, if the U.S. was willing to invest billions of dollars, something like 3-4% of its GDP on the space race, it's pretty unlikely they wouldn't have actually gone through with it, right?
Yeah.
Plus, there's all the physical evidence left on the moon, like, the lunar rovers and those retro-reflective mirrors that scientists use to bounce laser beams off of.
Right. I remember learning about those mirrors in school. They're still up there, and we can actually measure the distance to the moon with incredible accuracy by using them. That's pretty compelling evidence, don't you think?
It is. And as Chavda put it, why go through all the trouble of faking it when you can just, do it?
Good point. Okay, so if the moon landings were real, and we've got this renewed interest in lunar exploration, why haven't we been back since 1972? It's been over 50 years.
Well, Chavda argues that the original space race, it was primarily driven by those political motivations, like we talked about earlier.
Right.
But now, with the potential for all these valuable resources and, the possibility of establishing these lunar outposts, well, the game has changed.
Yeah.
He's suggesting that we're kind of on the cusp of this new era of space exploration, one driven by a combination of scientific curiosity, economic incentives, and maybe even just a sense of adventure.
I like that. It's exciting to think about all the possibilities, but it also feels a little bit, I don't know, like we're walking a tightrope here.
Yeah.
Like we talked earlier about the potential for conflict over resources on the moon.
Yeah.
And it feels like we're at this crossroads where we're capable of this incredible progress, but also, still prone to repeating the mistakes of our past. Did Chavda address that at all, like that tension?
He did. He acknowledged that, throughout human history, we've seen conflict.
Right.
And a lot of times it stems from, competition for resources, territorial ambitions. And he suggested that even with all our advanced technology, even with our philosophical ideals,
right,
we haven't totally shed those, primal instincts.
Yeah. So are you saying that we're, hardwired for conflict, doomed to repeat these same patterns even as we venture out into space?
Well, I don't think it's quite as clear-cut as that. Remember, Chavda also talked about the importance of us exploring our inner universe, through introspection and recognizing that sense of interconnectedness that we all share.
Yeah.
And I think what he was getting at is that we have this capacity for both immense good and, these destructive tendencies.
Right.
And the path that we choose, well, that's really up to us.
It's a sobering thought, but also kind of reassuring that we have a choice in all of this. So where does the scientific exploration, where does that fit into all of this?
And that's where I think you start to see this glimmer of hope. Because, Chavda, he really believes that science at its core is fueled by curiosity, right? This thirst for understanding the universe, our place within it.
Yeah, yeah.
And this pursuit of knowledge, he argues that it can actually be a unifying force
Okay.
for positive change.
So by understanding the cosmos better, we might actually understand ourselves better
Exactly.
and find new ways to work together
Yeah.
to overcome those primal instincts that you were talking about.
Exactly. It's about widening our perspective,
Yeah.
recognizing that we're all interconnected, and not just with life on Earth, but, with the universe as a whole.
It's a really powerful message. It reminds me of that Carl Sagan quote, where he says, "We are a way for the cosmos to know itself."
Perfect example.
Yeah.
That sense of wonder, that interconnectedness, that's exactly what Chavda is trying to inspire in all of us.
Well, he definitely accomplished that with me today. This has been, an incredible journey, and my mind is definitely buzzing with all sorts of new ideas.
Mine too. It's just exhilarating to think that we've only scratched the surface of what's out there. Every new discovery just opens up more questions, more avenues to explore.
That's what makes it so fascinating, right? It's not about having all the answers,
Right.
but it's about embracing the unknown,
Yeah.
the journey of discovery.
Precisely. And as Chavda so eloquently put it, science is driven by curiosity, by the pursuit of the unknown.
Yeah.
And that's a philosophy I think we can all carry with us, whether we're exploring the vastness of space or even just the intricacies of our own inner worlds.
Couldn't have said it better myself. A huge thank you to all of our listeners for joining us on this deep dive into the cosmos with Abhijit Chavda. Until next time, keep exploring, keep asking those questions, and keep that sense of wonder alive.